We're going to do two examples of binary addition to show how the carry works and then what happens when you have an overflow. At this stage, it's important to understand how binary works and that we have finite space to be able to store information. The second problem is going to show what happens when we go past that finite space. So first, let's add these two numbers, and this is binary in 7, and this is binary 6, which means we should get 13. So this is a good sanity check to put down here. So 1 and 1, what's actually happening is we have an initial carry in of 0. 0 plus 1 plus 0 is going to be 1 with a carry of 0. 0 plus 1 plus 1 is 2, which is going to be 0 with a carry of 1. Here we have 1 plus 1 plus 1, that's 3, which is 1 with a carry of 1. And we have 1 plus 0 plus 0, which is 1. In the previous videos, we've seen that 1, 1, 0, 1 is in fact 13. Now, the key to understanding the second problem is that we're going to limit our space to calculate this unsigned binary integer with 4 bits, which means that if we have two numbers with 4-bit inputs, we need to calculate this and solve it with a 4-bit output. So let's go through this step again. This is 15 and 13, and the answer should be 28. So let's go through the process. Initial carry in of 0. 0 plus 1 plus 1 is going to be 2, so that's 0 with a carry of 1. 1 plus 1 plus 0 again, 0 with a carry of 1. 1 plus 1 plus 1 is going to be 3, so that's 1. And 1 with the carry of 1. And then 1 plus 1 plus 1 is going to be 3, that's 1 again. So what's going to happen is we don't have numbers over here because we physically don't have that information. So what would happen is we would expect this to have 0 and 0 and have a carry of 1. However, because we only have 4 bits, what's going to happen is that this is going to represent this as 1100, which is actually 12. And we have what's going to be known as overflow. This is going to be really important when we start programming in C using integers, signed and unsigned integers, as well as single precision and double precision floating point. We have to ensure that the values we calculate inside the computing device can be physically represented in the system. So it's important for you to be able to understand this at this very early stage in your programming career.